Hey guys, so if you've been to one of my science camps before, you know there's basically kind of three parts that we do. We do demos, we do some sort of experiments where you collect some data, and then we have usually something we build, some kind of thing we make with what we've learned. So today for the experiment, we're going to try to figure out really what is the speed of sound, how fast does sound travel. What I've found works the best is if you can go to like a neighborhood elementary school or something, because they usually have like a big wall somewhere, you know, kids play wall ball and stuff off it. You guys have probably done that before. And usually on the weekend there's not that many people around there. So what you're going to be doing is you're going to be over here making some sort of a loud noise. What I like to do is use a couple of pieces of wood like this, and I'll slap them together, which is a loud sound. Or you can kind of slap them like this. Be careful to keep your fingers out of the way because you can pinch them. You can hit them together and it kind of makes a large distinct crack that then you can hear. What that sound wave is going to do is that thing is going to travel to the school. So you're going to be out in the field by the school. It's going to hit it and then it's going to echo back. And your helper person here is going to have some sort of a timer, and they're going to figure out how many seconds it takes the sound to go all the way there and then come all the way back. It's going to be fast because the speed of sound is fast, but usually you can measure it if you get far enough away. So why this works well is that echoing off a school actually doubles the distance because it goes there and back. So you don't have to be as far away, the two things. Like the two people don't have to be as far away because you're really doubling the distance. So the way we find speed on average for anything is we take the distance that something travels and we divide it by the time. Let's measure the distance in feet and let's measure the time in seconds. So whatever answer you come up with here, it's going to be in feet per second. So you'll get your answer and go in the magic cloud there. So you need to find a way then to find the distance here. If you have a really long tape measure, that works well, but not that many people have something like that. So another way is if you have an extension cord that's like 25 feet long or even 50 feet is better. You can lay it out, and okay, there's 25 feet, put a mark there, have someone stand there or something, 25 more feet, 25 more, and that can get you out there. If you don't have that, you could use a tape measure, but they're kind of tricky sometimes to use and not bend up in this situation. But you could do that. Or you could use a rope, if you know how long the rope is. A last way you could do it, if you don't have another method, is simply count your steps. How many steps it takes you to go from the school to where you are, and then you can double that distance. Make sure you always double it because the sound is going there and back. So get your distance, and then you're going to get your time. You can use a watch or a phone or whatever. I just have like a lot of people, an app on the iPod here that can do it. You can use that or whatever works for you. So I would try this 5 times. And then what I would call your answer is whatever time seems to be in the middle. So if you have some big times and some small times, pick the time out of those 5, that seems the middle one. So let's say it's 4 point, well, it won't be that big. Let's say it's 1.1, 0.8, 1.5, 0.9, and let's say it's 1 second. So I look at those, and which one seems like it's the middle one? Well, 0.8 is the smallest. 1.5 is the biggest. 1.1 and 0.9 are the next bigger ones and smaller. So 1 second would be right in the middle. So that's what I'm going to use here for my time. And if my distance had been, let's say it's 200, I'm just making this up, I don't know. Let's say it's 300 feet. Then my answer in this made-up example would be 300 feet per second for the speed of sound. And you can have your parents look up, or you can look up like typically what the speed of, excuse me, speed of sound is in feet per second, if you'd like. So that's the experiment for this one. And feel free to email me at my email, which I send with the link to this video, with any results that you got, because I'm interested in seeing that. Now finally, for the build portion, it's not really going to be a build so much this time, is these wine glasses, getting them to sing is a really cool demo. Like, just think about you at Thanksgiving time or something. You know, before everyone sits down, you can be like, everyone, I have a little demonstration I would like to do before dinner. And you take the glass in front of everyone, you know, no pressure, you know, and you make it sing. That would be cool. Okay, that would be something that would be impressive. You could also do it at Christmas dinner or something like that, or just anytime you want. So what I want you to do is to get a hold of one of these wine glasses at a thrift store, or buy one at Walmart for cheap. I think I bought one once for 88 cents at Walmart. So they're not like real fancy ones or anything. And you might have them in your cupboard already. But it's to really practice to getting this to work. And I want to see videos of you doing it. So feel free to send me back videos of you doing it. And if you really want to go above and beyond, get several of them and try to play me some kind of a song. And that would be, you know, that would be like A+ work right there if you can do that. So, sound is cool. This is just a little bit of a tidbit of what sound basically is, how we measure it. I hope you've enjoyed it, and I hope you keep watching. Thanks.